Hi, my name is Anil Kumar. In this session, I am going to be discuss about the optimal binary search tree. It's simply labeled as OBST. So first, I will recall what is binary search tree. I hope you are good at binary search tree. Once again, I want to recall. So binary search tree is nothing but a binary tree with the searching principle of if the tree is look like if it is a root and it is the left children and if it is the right children, I think the trees look like in this way. Either it may be having the only one children, it may be the left or right, or it may not be having both children if it is a leaf node. But when we have a tree look like, the principle must be the left children node value must be less than or equal to the root, and root value must be less than or equal to the right children value. So that means a left children value must be less than or equal to the root value, and root value must be less than or equal to the right children value. So this is the property we are following in the binary search tree. So now our topic is optimal binary search tree. So what is the meaning of optimal binary search tree is nothing but we are going to be construct the or choose the binary search tree with minimum number of searchings. So that we technically call optimal binary search tree. Once again I am repeating. So you are going to be construct the binary search tree for this property, following this property for the given set of elements, and the tree search cost must be the minimum. For which binary search tree having the minimum search cost, that we technically call optimal binary search tree. So here the question for us is, how many binary search trees are possible with n nodes? When we have 3 nodes, nothing but 3 key elements, we have 5 different ways to construct the binary search trees. For example, our keys are do, if, while. So here the face value is nothing but the dictionary words like do is smaller than the if, and if is smaller than the while, and if is larger than the do. So when we have these 3 elements like do, if, while, these 3 are our keys or nodes, we have the 5 ways to construct the binary search tree. Observe, this is the one way, this is the second, this is the third way, this is the fourth way, and this is the fifth way. So maybe if you are going to be give the generalizing with the n keys, how many binary search trees are possible to construct? Remember, 2 power n into 2 into n Cn by n plus 1. In other words, 1 by n plus 1 of 2n Cn. For example, here our n is 3. What is the value of 2 into 3? C3 by 4. So what is the 2 into 3? 6. 6C3. Nothing but 6 into 5 into 4 into 3 factorial by 3 factorial into 6 minus 3. 6 minus 3 once again 3. So 3 into 2 into 1. So we have 1 by 4 along with nothing but this value by 4. So what is this meaning? So 3 factorial cancel. 3 into 2 6. This 6 we cancel. Nothing but 5 into 4 by 4. What is the value we are getting? 5. So this is the important formula. Remember, in competitive exams also going to be asked, with n keys, how many binary search trees are possible to construct? 2n Cn by n plus 1. So for 3 keys only we have the 5 binary search trees. So we are going to be construct the 5 different binary search trees. For each tree we are going to be construct the cost, searching cost, and when you find the 5 binary search tree cost, then only we are going to be say then binary search tree casts are compared with one another, then only we are going to be say which binary search tree is efficient, nothing but the optimal. Let us assume, but when you are talking about in the real world problem, our keys may be 5 or within tens, within hundreds, like. So the number of binary search trees are very huge count, unable to construct. Those are all binary search trees, unable to find each and every binary search tree cost, and unable to compare. Those are all binary search tree cost. Unable to here in the sense which takes very huge amount of time. So to overcome this problem, the optimal binary search tree we are going to be solved by using the dynamic programming. So in the dynamic programming, we are going to be use tabular method. In the tabular method, or with the help of tabular method, with the help of one recursive formulas, we are going to be fill the values, and finally we are going to be get which binary search tree is the optimal for it. We are going to be see with an example that one. So before we discuss about that example, I am going to be explain how you are going to be calculate the binary search tree cost. So any binary search tree is having the cost with the help of two frequencies. So one is for which key element we are verifying. For example, in this case we have the three key elements, do, if, while. So my number of keys are 3, and my first element is do, second element is if, and third element is while. So the frequency for searching in the sense I am verifying do, nothing but how many times I have searching for do. So that frequency I labeled as a pi. So that frequency for searching do is like a 3, and if maybe 3, and while maybe 1. So if you are clearly observe, when you construct the binary search tree, if I am searching for the key element do, so maybe I am going to be search for the word like a can. So where the can is going to be find in the binary search tree, we know the principle. So can compared with while, smaller, traverse to the left side. Can compared to the if, smaller, can is a smaller, traverse towards left. Can with do, can is a smaller, traverse towards left. Now we have the only 3 keys, but there is no key with the can. So it must be the unsuccessful search. In other words, we are searching the key which is not available in the list. So that we technically call unsuccessful search. Unsuccessful search, if you are clearly observed for 3 elements, the smaller, nothing but up to do, what are the words we have? Smaller than do, those are all the left. And do larger and smaller than if, those are all occupied the do right side. And larger than if and smaller than y, if right side, this one. And the words which are higher than the while, these are all occupied in the right side, like a dictionary words. Nothing but for 3 keys, how many unsuccessful cases we are going to be get? 4 unsuccessful. Good. So now we are going to be maintain with one more label for the unsuccessful search. So like the elements for 3 is this is the first element, second element, and third element of 3 elements. So for the unsuccessful search we have the 4. I assuming this is the Q0, like 1, 1, 2, 2, like. So what is the frequency we have? So that's our convenient, and based on the problem we are going to decide for the successful frequency as well as unsuccessful frequency. So when we have the successful frequency as well as unsuccessful frequency, we are going to be maintain the levels also for this tree. For example, when I consider the like this example, if I observe or consider this example, how many levels it having? Yes, this is the level 1, this is the level 2 and it is the level 3. So if you consider the level 1, so level 1 nothing but if you are searching for the if, how many comparisons it takes? Only 1. If you are searching for the do, how many comparisons it takes? 2. And while also 2. If you are searching any word is smaller than this do, how many comparisons it takes? If and do, nothing but it also takes the only 2 comparisons, but the level is 3. So clearly understand, my dear. Once again I am repeating, when you are talking about this case, nothing but our word is more than 2 and smaller than if, how many comparisons it takes? It takes only 2 comparisons. So nothing but I traverse towards left and I traverse towards right. So here I am not comparing anything, so that's why it takes the 2 comparisons. It also 2, it also 2. So the total number of comparisons for unsuccessful node, the at max for this case is only 2. So I hope you understand. For this successful and unsuccessful frequencies along with the level, we are going to be give the one equation to find the binary search tree cost. That equation is like this one. So which successful key we are searching, that key frequency into that key can be available at which level. So I am going to be find the binary search tree cost for second one. So the second one I am going to be construct here. So if, yes, what is the if frequency? Let us assume the if frequency may be what is the frequency we set for the if? 3. So that means I am going to be search 3 times for the if, and at which level it is available? It available at the first level. So that is nothing but 1 plus at which level do is available? Second level. And what is the do frequency? 3. So 3 into 2 plus and for the while, what is the while frequency for successful? 1. Okay, and at which level it is available in our second example? Second level. So that is nothing but 1 into 2. So these 3 are the successful, plus we must be considered unsuccessful also. Unsuccessful all nodes available at level 3, but how many comparisons it needs? It takes only 2 comparisons. Good. So that's why the frequency for the first one, nothing but the smaller words than do, that is 1. Let us assume. So 1 into number of comparisons are only 2, nothing but the level of that availability of unsuccessful key minus 1. So that's why level of that node minus 1. So this formula. So plus, and what about the second one? Second one frequency also 1. So like 1, and that is also level 3 minus 1, nothing but 2 plus for the third and fourth, like that is the 2 frequency. So 2 into 3 minus 1, nothing but 2 plus, and the fourth one 2 into once again 3 minus 2, 2. So the total value 3 plus 6 plus 2, nothing but 9 plus 2 11 for the successful. For the unsuccessful, 2 plus 2 plus 4 plus 4, nothing but 8 plus 4 12, that is nothing but the 23. So the second binary search tree cost is 23. So in this way we are going to be find all binary search tree cost. Then which binary search tree cost is very small, then we are going to be conclude that is our optimal binary search tree. So I hope all you are following my class as of now. So now we are going to be solve the same without constructing the binary search tree for each and every one. I am going to be take the help of tabular method by using dynamic programming. So in the tabular method, I am going to be assuming the initial case as well as the recursive case. Initial as well as the recursive. Now let us assume we have the 4 elements and the elements are do, if, int, while, and its successful frequencies are 3, 3, 1, 1, and for 4 elements how many unsuccessful cases we have? Good, 5. So for 5 unsuccessful cases are 2, 3, 1, 1, 1. Now we are going to use the tabular method. So I am going to be form my table size is number of elements plus 1 rows by number of elements plus 1 columns, and my initial case is I am going to be maintain the row index as well as the column index. So my row index is like I and my column index is like j. So here the initial case is I value must be same as the j value. That means 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. For each cell, we are going to be calculate 3 values. One is the weight, nothing but W of ij, W of 0, 0, W of 1, 1, W of 2, 2, W of 3, 3, W of 4, 4 like, and also for each cell cost, what is the cost? Binary search tree cost, C of 0, 0, C of 1, 1, C of 2, 2, and so on. And also for finding the root, we are going to be maintain the for which smallest k value we are getting that equation or that cost with the help of R, that we technically call to construct the binary search tree. I am going to be take the help of the third variable like R 0 0, R 1 1, R 2 2, R 3 3, R 4 4. Initially Wij, Cij, Rij, nothing but Wij is nothing but the Qi, Cij and Rij both are the 0. That is the initial if and only if when my I value is j. What is that meaning? If I is 0, j also 0, then my cost is 0 and rank also 0. What about my weight? My weight is nothing but Qi. So what is my I value? 0. What is the Q0? 2. In the same way for W11, C11, R11, because that is our initial case. Initial case is nothing but the difference between j and I must be the 0. So like 1 1. So yes, what is R11? 0, C11 0, W11 Q1 value, nothing but the Qi value. What is our I? 1, nothing but 3. In the same way for 2 2, R22 0, C22 0, W22, nothing but the Q2. So this is the Q0, Q1, Q2. What is the Q2? 1. In the same way for 3 3. What is R33? 0, C33 0, W33 Q3 value, nothing but 1. And finally 4 4, R44 0, C44 0, W44 Q4. What is the Q4 value? 1. So I first fill the initial case. Now I am going to be repeat nothing but I am going to be find with the difference 1 of j and I. So with the difference 1, what is the cells I am going to be get? Like 1 2, 2 3, 3 4. So first I am going to be fill 1 2. So 1 1 2 2 3 3 4 and also 0 1. So this is I, the first one is I and the second one is j. So the difference is 1. So 0 1 value. So for these I am going to fill with the help of recursive formula. So the recursive formula is this one. For the Wi is nothing but previous weight in the same row, nothing but the Wi j minus 1, the same row, nothing but the 0th row. When I am going to be find W01 in the same row, previous column, nothing but W00. Then what is the principle? I fix j minus 1 like this one, Wi j minus 1 plus the corresponding frequency of successful and unsuccessful with respect of j. So what is our j value? 1, nothing but pj plus qj. So what is the previous previous weight? Nothing but W01 minus 1. I am going to write here W01 is nothing but the W of the same row, but the column is minus 1 plus successful and unsuccessful with the same j. So j. Here what is our j? 1. So that's why I am going to be consider P1 Q1. What is the 1 minus 1? 0, which becomes W00. What is the W00 value? 2. So simply 2 plus what is the P1 value? 3 plus what is the Q1 value? 3. So 2 plus 3 plus 3, nothing but 8. We are getting this value. What is a C1? I hope you following this one. Now I am going to be find the cost. Cost of Ij I am going to be find with the principle of minimum of the same row earlier cost, the same column earlier cost. Sir, what is that meaning? So column of I k minus 1 plus column of k j plus the corresponding weight. Sir, why you are saying one more variable like k? My dear, this is a recursive formula. When you are going to be find for the cost of 0 1, we have the only one earlier column and a earlier row. So this is our earlier row as well as this is our earlier column. But when you go for like if you are going to be find column of 0 4, how many rows we have earlier? 4 rows. How many columns we have? 4 rows. So that's why I am going to be use one more variable. That variable is k. The k value must be greater than the I and must be less than or equal to the j value. Remember it. The k value must be greater than I. So k value must be greater than I and k value must be less than or equal to j. If I try to combine these two conditions, then what is it? When I less than k less than or equal to j. So like this one. So C of I k minus 1 plus C of k to j. What is the minimum we are getting? That one plus weight of Ij. So now we are going to be find this one minimum of, so C of the cost of I. What is our I? 0 comma. What is the k possibility? K must be greater than 0 and less than or equal to 1. That is nothing but it having only 1, k equal to 1. So that is nothing but C of 0, 1 minus 1, 0 plus the C of cost of k. What is my k? 1 comma j. What is my j value? 1. So this is our j and this is our I. 0 is the I and j is the 1. See 1 1 plus weight of Ij. So what is the I? 0 and what is the j? 1. So that is nothing but what is the minimum of, what is the C00 value? 0 plus what is the C11 value? 0 plus weight of 01. What is the weight of 01? 8. So what is the 0 plus 0? 0. Minimum of 0? 0 itself. So 0 plus 8? 8. So that is our cost. So now observe. So this 8 is given by which k value? 1. So that is our R01 value. So that is nothing but R of ij is the k is the smallest k value. So that is nothing but 1. So is it clear? So now we are going to be evaluate the next with a difference one. The next with a difference one is 1 2. So we are going to be find W of 1 2, cost of 1 2 and R of 1 2. What is the W of 1 2? W of 1 2 is nothing but the same earlier weight. What is earlier weight? 3. So 3 plus what is our J value? 2. Pj Qj. What is the Pj value? 3. What is the Qj value? 1. So 3 plus 1? 4. So simply I am going to write weight of 1 comma 2 minus 1 plus Pj plus Qj. So J is nothing but 2. So P2 plus Q2. That is nothing but what is the W11? 3 plus what is the P2 value? P1 P2. So 3 plus what is the Q2 value? Q0 Q1 Q2. Remember unsuccessful always begin with indexing 0. So 1. So what is the value it having? 7. So that is the 7 I am going to be assigned for 1 2, weight of 1 2. Now I am going to be find the cost of 1 2. So minimum of what is my k value? K value must be greater than 1 and less than or equal to j. So that is nothing but it having only 2. So minimum of cost of I. What is my I? 1. What is my k? 2. So k minus 1 nothing but 2 minus 1 1 plus cost of k nothing but 2 and j. So j also 2 nothing but the cost of 2 2 plus W 1 2. So weight 1 comma 2. So what is the value of C11? 0. What is the value of C22? 0. So nothing but the minimum of 0 plus 0 plus what is the weight of 1 to earlier calculated? 7. So 0 plus 7 nothing but the 7. So that is our cost. And this cost value for which R value? Minimum k. What is the k? We have the only one itself, it is a minimum, for that is 2. So in the same way we are going to be find for the W23, C23 and R23, in the same way for W34, C34 and R34. Now we are going to be find with I and j with the difference 2. So I and j with the difference 2, nothing but the possible cells are 0 2, 1 3 and 2 4 like diagonal 0 2, 1 3 and 2 4 like. First we are going to be find the same W 0 2. So what is the W 0 2? So W of 0 2 nothing but the earlier white in the same row. So W of 0 comma 2 minus 1 nothing but 1 plus Pj Qj nothing but P2 plus Q2. What is the W01 value? 8. So that is nothing but 8 plus, what is the P2? P2 3 plus, what is the Q2? 1. So what is the total value? 12. So like 12. In the same way for, so W13, W24. First I will fill the weights. What is the W13? 7 plus P3 Q3. What is the P3? 1. What is the Q3? 1. 1 plus 1, 2. 2 plus 7, 9. In the same way for W24. What is earlier? 3. So 3 plus P4 W4. 1 plus 1, 2 plus 3, 5. Now I am going to be find the cost. So what is the cost of 02? Now observe clearly. Cost of 02 is nothing but the minimum of first equation I am writing. So what is the k possible value? Greater than I. Yes, 0 greater than is 1 and less than or equal to j. Nothing but the k with 1 and 2. With the k equal to 1, what is my equation? C of I 0 comma k minus 1, nothing but 1 minus 1, 0 plus cost of k, nothing but 1 with j, minimum of that one, or we have the one more with the k. If my k is 2, if my k is 2, what is my equation becomes? C of I k minus 1. What is my I? 0 comma k minus 1, 2 minus 1, 1 plus cost of kj. K is 2, j also 2. So minimum of these, either this value or this value, plus weight of, what is the weight of 0 2. Earlier we calculated the value. So now simplify this equation. What is the thing we are getting? So minimum of C00 0 plus C12 7 comma, what is the cost of 01? 8. Good. Plus what is the cost of 22? My dear, from this table you will find. So 8 and C22 0. Plus what is the W of 02? W of 02, 12. So now the minimum, which is the minimum, either 0 plus 7 or 8 plus 0, 0 plus 7 is given by which k value? 1. So remember it. So 7 plus 12 is nothing but 19. So what is the cost of 0 to 19? Which minimum k value? 1. So that is our R02. Okay. So I am going to be evaluate now C of 1 3. If you have any doubt, now it is going to be clarified. So please observe carefully. So now already we evaluate the weight of 1 3. Now we are going to be find the cost of 1 3. So that is nothing but the minimum of k value greater than 1 and less than or equal to 3. So k is with 2. If k is 2, what is my equation? I k minus 1, 1 comma 2 minus 1, 1 plus cost of kj 2 and j is 3 now, comma, if k equal to 3, 3 also possible because k value must be greater than I and less than or equal to j. Yes, less than or equal to 3. Then my equation becomes C of I k minus 1 2 plus C of k 3 and j 3. This value plus weight of 1 3. Now what is the C of 1 1 value? 0 plus what is the C of 2 3 value? 3, comma, what is the cost of 1 2 value? 7 plus what is the cost of 3 3? 0 plus what is the weight of 1 3? Earlier we calculated 9. Which is the minimum? Either 03 or 70. 03 is the minimum. Is given by which k value? 2. So 3 plus 9, 12. So the cost here is 12. And R13, nothing but the minimum k value is 2. Like in this way, we are going to fill the entire table with a W14, C24, then R24 with the difference 3, 0, 3, cost 3, and also R3. Then with the difference 3, 1, 4 with weight, 1, 4 with the cost, 1, 4 with the rank or root. And finally, we reach to the with the difference 4. The max difference is the given number of elements itself. So that is nothing but 4 minus 0 is the 4. So weight of 0, 4, cost of 0, 4, and R of 0, 4. So finally, we are getting the table is like the final value is cost of 0, 4 is 32 and rank is 2. So now we are going to be construct the optimal binary search tree. We know the optimal binary search tree cost. What is that cost? 32. For which binary search tree gives us the cost 32, we are going to be check it, and also we are going to be reconstruct the binary search tree with the help of this table. So my dear, the rank R04 tells us the second. What is second? Nothing but the second variable. What is our second variable? If first one do, second one if, third one int, and fourth one y. So that means I am going to be construct my binary search tree with root is if. So if that will be given by this equation. So what is this k value? 2. So if k is 2, what is the left side? The actual equation? Cost of, what is our I? 0. What is our j? 4. Nothing but I 0, k 2, nothing but 0, 1 plus cost of k 2, 4, j is. So like our equation for this is this one. So that means my left side is I want to find, and my right side is I want to find. My left side is given by this left side C01. I go for the C01. C01, this one. What is the rank? 1. What is the first element? Do. So that means this is the do. So for this do, nothing but for which k value it gives us? 1. 1, my rank is 1. What about my equation? C of 0, 0 plus C of 1, 1. So that means I traverse towards left as 0, 0. That is the one more node, but that is not the key element, unsuccessful case. And right side is 1, 1. 1, 1 is not the element. So that is also unsuccessful case. Now come to the right side. If left side we completed, come to the right side. What is the right side equation? This one, cost of 2, 4. Now go for the cost of 2, 4 is given by voucher rank 3. That means C k equal to 3. If k equal to 3, what is my equation becomes? C of what is the equation? 2 I. Yes, our I is 2. 2 minus k is 3. So 3 minus 1 is 2 plus C of 3, 4. Good. So that means my left side is this equation and right side is this equation. What about my left side? Left side is unsuccessful, C of 2, 2. Now come to the right side. Now R is 3, R24 is 3. Nothing but what is our third element? Integer. Now go for the C of 3, 4. If C of 3, 4, yes, C of 3, 4, what is my rank value? 4. So what is that means? This equation gives us the cost of 3, 3, 4 minus k is 4. 4 minus 1 is 3 plus cost of kj, k also 4, j also 4. So that means the unsuccessful left C of 3 3 and unsuccessful right cast of C 4 4, and this is our 4, nothing but the while. So for this binary search tree, we are going to be get the cast as, what is the cast? 32. So manually we'll check by using that formula. What is that formula? This by using this formula, check it by using this formula. Definitely we will get this, the cast as 32. So this is about the optimal binary search tree. My dear, in some textbooks it may be the trees look like this is the top and this is the, these are like a triangle shape. Don't worry, when it is a top, what about this one? J, and what about this one? I. So this is about the OBST, and this is about this algorithm. So thank you. If we follow the dynamic programming method to construct the optimal binary search tree, then what is the time complexity? The time complexity is look like a tabular size. Then what is the table size? N plus 1 into n plus 1. Then what is the higher term? N square. Good. So the time complexity is order of n square. So thank you, one and all.